Okay, so in this lecture, we're going to look at the naive search solution in code. Okay, so just to reiterate, the previous lecture looked at the pseudocode for this, and now we're going to the actual code. So I hope that you've tried to implement the pseudocode yourself, so doing what we're doing now by yourself, before watching this video. Okay, so this video is kind of like the solution to the exercise. So we'll begin by creating our function. So def naive search, and this takes in a matrix A. Okay, so if this were maybe a language like C++, we might need to also have as arguments the size of the array, but because this is Python, that's not needed. Okay, so we'll begin by initializing our variables. So we'll have max ones. So this is going to keep track of the maximum number of ones in each row, and this is going to keep track of the index of the best row. Okay, so then we're going to loop through each row in A, and we're using enumerate so that we also get back the index on each iteration. And then here we're going to count the number of ones in this row. So we'll initialize num1s to 0, and then we'll loop through each column in the row. It's really just accessing one cell at a time. So for C in row, so C stands for cell, num1s plus equals C. So if C is a 0, it won't add anything, and if C is 1, then it'll add 1. So at the end of this loop, we end up with the number of ones in num1s, as expected. Okay, so the next step is to check if num1s is greater than max ones so far. And if it is, we have max ones equal to num1s. So we're setting max ones to the best num1s we've seen so far. And we set the best row to this row because it's the best row we found so far. Okay? And then, by the end of this, we will have our best row, and then we can just return best row. Okay, so let's run this. And now let's test out our function. So let's create some dummy data. 1, 1, 1, 1. Say 0, 0, 0, 1. Okay, so and as part of these coding exercises and these coding interview questions, part of the question, the interviewer might just say the input is a matrix, but they won't specify how the input is formatted. So understanding that this is how we format a matrix, or this is how we represent a matrix in a computer, is actually part of your answer to the question. Okay, so that's something to keep in mind as well. So you should know things like, this is how we would represent a matrix. In any case, let's try our function to see if this works. And the answer is 1, and that is indeed the row with the maximum number of ones. Okay, so let's try a different example. Why does it do that? So for this one, we're going to say the whole matrix is zeros. So this is kind of an edge case test. But we want to see that our function still works. Okay, and so as you can see, it still works. Now, here's one subtlety about this question. And so this is something you could discuss with your interviewer and decide how you want to approach it, is what should happen if the matrix doesn't contain any ones at all. Okay, so you can see here we've returned 0. And I think this is a valid answer because 0, the 0th row, which is this one, can be said to have the maximum number of ones. It has 0 ones, which is the maximum number of ones. Okay, so that does make sense. But another way of looking at this is that no rows have any ones, And so you could also just return the sentinel value of -1. Okay, so I would consider both of those to be valid answers. And it just so happens that in this particular implementation, we are returning 0 instead of the sentinel value -1. Now, one thing we could do is to say, well, we do want to return -1 if there are no ones in the array. And so one way to accomplish that, well, let's just try it out. I'm doing it live. So we'll see if it works, but I think this should work if we set the max ones initialized to 0. Okay. And then we run this again. Yeah, so now we get -1. So it depends on how you initialize. That'll determine the convention of what you should return when there are no ones in the array.